In this video, Lee is going to be adding in the overloads for his well 512 implementation.
Yep, we're going to have three overloads for this one. Basically, what I want to be able to do is not only call this next, which is going to return a double between the 0 and 1 range. I want to be able to return a double between a range of two numbers, a min and max. I'd like to be able to return a float between a min and max. And I would also like to be able to return an integer between a min and max. So to do that, I need to do the calculations to convert what is getting returned from next into a range that we specify. So we're going to make a private method to do that calculation for us. So it's going to return a double. I'm going to give it a really ingeniously creative name like calc in range. It's going to take in a double min, a double max, and a double val, which is actually going to be the random number that we get. From there, the first thing I want to do is make sure that our min and maxes are literally in the right place instead of backwards. So we'll do a check to see if max is less than min, then we need to swap them. So we'll make a temp variable. We'll assign it the value that's in min. We'll take min, give it the value that's stored in max, and then take max and give it the value that we temporarily saved in the temp variable. That will swap out the two if they're reversed. Then I want to create another variable called diff, and that's going to be the difference between our max and min. So I'm going to take our max, subtract min from it, and we're going to return our min plus our difference, or our diff, times our value, or val. Now, this is going to work because our next value, or the value that we're putting in, should always be a range of 0 to 1. So when you take a fraction, multiply it by another number, we get a fraction of whatever that's going to be, with 1 being the entire value of difference, and anything less than that, a fraction of the difference. And we add that to our min value. So even if value is at 1, we can never be greater than max, and if value for some reason is 0, we can never go less than min. So this will return a number within the min and max, and it will always return doubles. Now let's make our overloads. Our first overload will be a public double, and this will be next, and it's going to take in a double min, a double max, and to make this work we just say var val equals next. This will get us the next number in a sequence, which will always be between 0 and 1 because of the way we coded it, and we will return whatever we get back from calc in range. We pass it our min, our max, and our value. Because it's a double and calc in range is returning a double, we don't need to do any casting. That's all we need for the first overload. The cool thing with this is our next two overloads are pretty much the same thing, except our second overload is going to return a float. Third overload is going to return an int. So for our float, I cast what we get back from our calc in range to a float. And for our integer, I cast it into an integer. Now with the integer one, I want to do it a little bit differently though. I prefer my integer random number generators to be inclusive, meaning when I tell it to give me a number between say 0 and 10, I expect the minimum number that I get to be 0 and the max number that I get to be 10, unlike some random number generators which will give me 9 is my maximum number. And even some of them will give me a min of 1. So they'll be exclusive, not inclusive. And that drives me nuts because then I have to go and modify the numbers differently. So I'm going to round what we send in. And IntelliSense decided that I didn't really want it to calc in range after all, so I'll have to fix that. So what it's going to do is it's going to take whatever my calc in range is, and it's going to round it. So if I end up with a number, let's say my min is 0 and my max is 10, and my value comes out to be something like 0.98, it will multiply 0.98 by 10, or the difference between min and max, which would be 10, which would give me a number of 9.8. But with round, that would give me a nice round 10, as opposed to truncating it off and just giving me 9 back.
Right.
So now, because these are identical signatures, I have to modify the signatures as well so it can tell what overload is which. So I convert that to floats and convert these to integers. I built these out, and that should work. Now, we can do a real quick test of these. So I can copy this line, paste it, coming out this one. Let's just do 0.0 to, let's make it 100.0. I'm not using the F because I want to use the double overload, so I'm just using dot or decimal places.
Yeah, just to prove that the range is working for doubles.
Yep. So if I build it, notice I got F5 working again.
Oh, what was it?
Apparently when I dropped my keyboard, I had turned off the function key part of it.
Oh, gotcha.
All right. Now, our analytics are kind of messed up at this point. If you look, we've done 1 million iterations. Our minimum number is really low because we're e to the negative 0.5, and our max is almost 100. So we are effectively at 0 and 100. What's messed up is our ranges. If you look at our ranges, yeah, we're still fairly close, but these numbers nowhere come close to adding up to 1 million. That's because we're using double, so it's counting the numbers up to 1, but those other 99 numbers that we've got in our range aren't being calculated, so our distribution's completely jacked up, so we can't go through that. But if we look at our mean, our average is real close to 50. Which is about halfway. We still got 0 duplicates. So that works right. Now I can come over here, convert these to floats, and I can run this. Again, 0 to 100 effectively. Distributions are still messed up. Still roughly about half on our mean, but we've got a whole lot of duplicates now. If you remember, we're using floats, and floats have only 7 places of precision as opposed to the really, really long number of precision that you get with a double. So because we've lost all that precision, we're now getting a lot of duplicate numbers because we've got a much smaller range of values in between 0 and 100 that we can work with. So that is working as expected. And if I go over here and delete the decimal notation, well, that was interesting. I think that was on my side, so you guys probably haven't seen that.
No, I didn't see a thing.
Yeah, I managed to bring up Logitech set point.
Oh.
So, yeah. All right, now this one gets really interesting. We're returning integers. Our min number is 0. Our max number is 100, so it is inclusive. We've managed to hit exactly one number at 0, exactly one number at 1, and we've got 999,899 duplicates. But we expect that because we're counting between 0 to 100, which is exactly 101 different numbers. So we've got 101 different numbers, and the rest are all duplicates. So that is exactly what we expect. It looks really weird, but when you think about what it's doing exactly what we told it to do. So, and I could also, just to prove a point, change this, say, to negative 100 to 15,000. Negative 115,000, and we have a lot less duplicates because we've got more valid numbers inside of our range.
Mm-hmm.
So it does accept negative numbers. And just to see what happens, because I like to press my luck, negative 15,000 a min, 1,500 for max. So it is doing what it's supposed to do.
Mm-hmm.
So
Awesome.
it even compensates if you mess up your min and maxes. So that was everything I wanted to show with the overloads.
Okay.
So I'm thinking about the only thing that we could really do if you wanted to do another video on is just do a comparison, do some tests of all the different methods.
Yeah, we can do that.
Do a side by side.
And then wrap up this little mini series, if you will. Cool. All right. Well, with that, that is going to conclude this video.